Good day, everyone. You are welcome to today's class. And in today's session, we are going to continue from where we left off on the topic limit of what functions, okay, which goes hand in hand with what differentiation. So usually it will be limit and what and differentiation. Okay, before you can appreciate the concept of differentiation better, okay, especially the first principle. Okay, you need to be well versed, very conversant in dealing with what limits. Okay, so in our previous lesson, we looked at limits of what special types of functions. We considered polynomial functions, okay, which was the first type of function, and the second type was rational functions. Okay, and you were told that whenever you have a polynomial function and you are taking the limits of that polynomial function, as x is approaching a particular value, just substitute the value that your x is approaching, or your variable that your function, in this case polynomial function, depends on is approaching. Just substitute directly. So for polynomial function, direct substitution is always allowed. However, okay, for a rational function, okay, you check whether the denominator will allow direct substitution. In that case, if you substitute, okay, the value that your variable, that your function, your rational function depends on, let's say usually x is approaching. If you substitute that one into the denominator function, because we are dealing with a rational function, it will be a numerator function and a denominator function. So if you substitute and you realize that the denominator function after substitution will give you 0, then it means direct substitution is not allowed. In that case, we need to manipulate. The fact that direct substitution is not allowed doesn't mean the limit does not exist. Okay, it only means that a little work, okay, possibly must be done before you can find the limit. Okay, so we said the work basically will be manipulation. And we dealt with one aspect of manipulation, which was what? Factorization. So anytime direct substitution is not allowed, for now, you know that the manipulation will be factorization. So you check your numerator and denominator functions. Any of them that is factorable, you factorize. Then you cancel whatever that, okay, could be canceled, or you reduce your rational function by canceling, okay, common factors, okay, or factor. All right, so we are going to continue from there. Today, too, our main objective will be how to deal with limits of functions, rational functions for that matter, continuation of questions, okay, a little more difficult. Then after that, okay, we'll look at, okay, rational functions, which will involve, okay, limits of rational function, which will involve another type of what? Manipulation. Another approach of what? Manipulation. And if time allows, maybe we'll look at limit of what? Functions in parts. Okay, so without much ado, let's look at the question before us. That's the word example number, okay, 3. If you look at word example number 3, obviously, we can see that we are asked to evaluate the following. So we need to find the limits of what? A. Okay, I mean A, we need to find the limits of this function B, so limit. So let's start. After writing solution, remember questions are numbered because we want you to equally number your solution. So you write the major question number there, oops, okay, which will be question number 3. Then you come to the minor question number, which is what? A. We are asked to evaluate. So A, what do we have? We have the limits, okay, as x approaches what? Okay, 5. And because of the nature of my digital board, that's the more reason why I'm writing this type of x. Okay, the x that looks like the multiplication. Otherwise, we should all desist from writing x this way. Okay, your x always, if possible, write it this way. Usually, if I write it this way, it looks like n and what have you. So if I will mention it, okay, the letter before I write, so you know and you'll be able to connect. So what we have here is a rational function. So my numerator I have will be x squared, okay, then minus what? 4x, okay, then minus what? 5. Then over what? X, okay, minus 5. So a rational function, remember we said anytime you are dealing with limits of rational function, your first concentration should be on the denominator function. So you ask yourself, if you substitute the value that your x is approaching, okay, into the denominator, will your denominator give you 0? Okay, so let's see, 5 minus 5, that will give us 0. So it means direct substitution is not allowed. All correct, my professors?
Yes, please.
Okay, so if direct substitution is not allowed, okay, remember we said that doesn't mean the limit does not exist. Okay, it means we need to check the numerator function, the denominator function. If any of them is factorable, we factorize and check if you can reduce. So denominator not factorable. Now let's go to the numerator. The numerator function that we have here. Okay, so let's look at it clearly. If you look at it clearly, okay, we thank God it's a quadratic expression. Okay, with the leading coefficient, with the coefficient of the x squared term being 1. Okay, so it means I concentrate on the constant term here, which is minus 5. So I find factors of minus 5, which when I add, I will get what? Minus 4. When I multiply, I will get minus 5. Which factor pair comes to mind? Which factor pair comes to mind, my professors? Hello, can you hear me? And the whole class. Factor pair. -5 and +1. Do you agree?
Yes, please.
Yes,
Okay, so once you have a quadratic expression and the leading coefficient is 1, remember those of you who were under my voice when I was walking you through factorizing quadratic expression, special situation when the leading coefficient is 1, you can factorize without going through the factorization by grouping once you get your factor pair. So in this case, okay, there's an expression. I start introducing my steps with equal to. So my first step, I'm not substituting the x value, so I still keep my limits. Remember, the limit as s approaches 5 must be written. Okay, and what do? I'm going to factorize my numerator. Remember we said, okay, the factors will be -5 and or +1. So you are going to get 2 factors. So I introduce my 2 brackets. Okay, because it is in x, my first will be x, my first in the second factor will be x. And the factors that we considered, remember we said -5 and 1. So I could write -5, then +1. I'm done with the factorization of the numerator. Then I come to x -5. All correct, my professors?
Yes, please.
Okay, very good. Okay, so at this point, we know this, okay, cancels that. But as you mature, don't show the cancellation. You can do the cancellation mentally. Okay, so I know what I have here. I will still write my limit because I'm not substituting. Okay, will give me, so the limit as s approaches 5 of the reduced function that I have here, x +1. Okay, so is that correct? Do you all agree?
Yes, please.
Okay, is that what you all write?
Yes, please.
So it's supposed to be over 1, but then so that every factor or something is over 1.
So you mean I'm supposed to write it over 1?
So please no. I say you are solving the material, so you don't have to write the over 1.
Okay, so I don't have to write over 1. So I should write it just like I have it there, right?
So please, you're supposed to bring. Okay, so I'm not supposed to bring anything. It's supposed to be like that, yes.
It's supposed to be like that. Any objections?
Yes.
Yes.
Okay, so, any objections?
Yes, it should be in a bracket.
Very good. Remember in the lesson, I told you, unless maybe you didn't watch. Okay, immediately you have more than a term and you are taking the limits of, if you don't put your expression more than a term expression, your monomial, more than monomial in brackets, the limit will only affect the first, okay, term. So please take note. So here, okay, you put this in brackets. So, oops. Point well made, my professors.
Yes, please.
Other than that, the meaning, okay, would change. So let me clear that. Okay, so the first one that I have there, oops. Okay, so that will look, okay, neat. So at this point, I know my next step, because this is a polynomial function and I'm taking limit of, meaning there is no denominator except 1. Okay, so what do? I can always do direct substitution. So the next step, I'm going to do direct substitution. And when I'm substituting the limit, okay, we'll go. I don't write lim again. So that will be equal to what? Wherever I see x, it is what? 5. So 5 plus 1, which in effect will give us what? 6. So in this case, remember, you can come and write therefore here. As simple as that. So your conclusion is embedded in your steps. Now, professors, is the explanation okay? Who wants me to come again and from where? Are we all fine, my profs?
Yes,
Yes,
sir.
please.
Okay, great. We thank God.
Please, can you go over it again?
Okay, Prof. Ernesto, from where?
Please, can you start again?
From the beginning. No, as for that one, I don't allow that. Because
Okay.
at every step, I ask you, are you okay? Are you okay? So if you don't talk, okay, other than you know it will not be fair. Okay, so as for that one, I won't allow it. Okay, other than that, also, if you get it, were you able to watch the video?
Yes, please.
Okay, so I'm going to do a second one on and maybe a third one. Okay, so try and get it from there. After that, if you don't get it, I know you will get it. Okay, after that. So this is the very first one. If I'm supposed to go back, you know. So I just want everyone to know that, okay, you know, that's why every step I ask you, are you okay? Are you this? Don't wait for me to get to the last part before you tell me to go back. Okay, that wouldn't be fair. Okay, so thanks for your understanding. Now let's look at B. Okay, B, what are we dealing with? We are dealing with the limit. So with this one, you know, okay, all lines here must be occupied. You'll be writing in lines. Okay, so you don't leave spaces in between your steps. You don't leave lines, okay, in between your steps. Okay, the only point where you leave lines unattended to will be where you are moving from a sub-question to another sub-question. Please take note, especially the new ones, okay, on board. Okay, so now, okay, we are asked to find the limit as s approaches 3. Okay, and those of you who were not with us the very first meeting, remember we said you will have lines. So if you are writing the limit, you write the lim on just on the line, and the x approaches, okay, just below the line. It shouldn't touch this line. So take note of that. I hope I'm clear enough. So limit of a rational function, my numerator function is 2x squared, okay, plus what, x, then minus what, 21. My denominator function is x, okay, minus 3. All correct, my professors?
Yes, please.
What was I looking for? Okay, so let me hope maybe that will work. Okay, the 21 looks, but it could be possible. So now, again, you are taking the limit of a rational function, the limit to a specific value, a particular value, in this case 3. Okay, so we check the denominator, whether direct substitution is allowed. So x, if x is 3, it should be 3 minus 3, so that would be 0. So direct substitution obviously is not allowed. Am I right, my professors?
Yes, sir.
Okay, so now I come and I know I'm going to manipulate. So I'll write equal to, then come and write my limit. Okay, as s approaches what? 3. Okay, now what do? I check my denominator numerator functions. Any of them factorable, I factorize and see whether I can reduce, okay, that rational function, okay, or I can cancel out. So let's see. Unfortunately, our leading coefficient is not 1, it's 2. So it means we cannot factorize straight away without going through factorization by grouping. Okay, so on that note, this is what I would advise you do. Okay, don't come and factorize in your main work here. Take whatever that you want to factorize. Okay, go and factorize that as your rough work. When you get your answer, then you import. Other than that, when you are factorizing the numerator, you have to still be writing the denominator, okay, from each step. I mean, yes, from one step to the next step. Okay, but your concentration is on the numerator. Why don't you take it out, deal with it, then import your result so that you don't write what will not be necessary? I hope my point is well made.
Yes, sir.
Okay, so this is how you simplify rational. Okay, so I'm going to take
Please, can you write it again?
Caroline. Okay, you know, I've told you anytime you are simplifying any rational expression, any factorization that involves more than a step, take it out, go and factorize as your rough work before you move on. So even if I gave you this one to simplify, okay, take any, with this one, you can see that I didn't take this one out to go and factorize because I knew factorization of this, because the leading coefficient is 1, we involve just a step. So with just a step, I'm able to factor, but with this one, I cannot factorize, okay, with just a step. I have to go through the factorization by grouping. So that means that I have to take it out. So I will take it out, go and do my fact. So this is where I do my rough work. So I'm going to have 2x squared plus what? X minus 21. So you multiply 2 and 21, okay, or minus 21. What would that give us?
Minus 42.
Minus
42.
So the number was okay. So let's see if it works. Fine. If it doesn't, we'll see how best we can. I can alter the question to meet exactly what I want. Okay. So are you able to get factors of minus 42 that you multiply? You get minus 42. When you add, you get plus 1.
Yes, sir.
Okay, which would be positive 7 and 6.
Negative 6.
Positive 7 and what? And negative 6. Do you agree?
Positive 7 and negative 6.
My professors, do you all agree that this will be the factor pair?
Yes, please.
Okay, so now we come and use these two factor pairs to split the middle terms. So we come and write 2x squared, okay, then plus, okay, so it's minus 6x, right? Then plus 7x, okay, minus 21. Okay, so group the first two, factorize, last two, factorize. Don't use bracket to group, remember. So if you mentally group the first two and factorize, numerical, okay, factor will be 2. Variable factor will be x. Okay, then that gives us what? X minus 3. Then plus, okay, here numerical factor will be 7. Okay, then you get x minus 3. All correct. Okay, so your last factorization will be 2x, okay, plus 7, okay, into what? X what? Minus 3. My professors, I hope my point is well made. Is everyone fine up to this point?
Yes, sir. Yes, sir.
Okay, great. Okay, so Prof. Naki, yes, like I said, I always want to encourage you to talk in class. So once you are in class and your audio is fully functional, your mic is fully functional, please, okay, put up your hand and ask questions. Because sometimes it takes me a while before I realize that someone has sent me a message by the chat. Okay, by then maybe the answer to your question will be too late. Okay, so I will encourage anyone, once you are in class, unless where you are is noisy or you have issues with your mic, okay, ask your questions verbally, okay, rather than via the chat. Okay, so thanks for your understanding once again. So yeah, please, marks will not be taken, okay, from, so the marks for the factorization, because this your rough work is still on your paper, okay, your answer sheet, okay, so it will still be seen. So the method mark for the factorization will be given here. So you won't lose any marks because there is evidence of work. If you skip, okay, this and straight away you wrote, okay, let me finish. So if you skip and straight away, you from here to here, you just came to write 2x plus 7, okay, and what? X minus 3. So times x minus 3 over the x minus 3. So if you skip and straight away came to write this, okay, you won't get the method mark. In some situation, once you don't get the method marks, we won't give you the answer mark too. So you tread cautiously. Okay, Prof, is it Ernest? I saw a hand up.
Sir, it was me.
Okay.
If we don't decide to use a factorization method, like for an example, whenever we see x, we just put 3. So instead, we do it 2 times 3 squared plus 3.
No, it can't,
And
because we cannot substitute 3. That's why we said rational function, we check the denominator first. If the denominator, if you substitute and it won't give you 0, then direct substitution is allowed. So 3 obviously will be out. It's because we realize that we can't directly substitute the 3. That's the more reason why we are doing all this. so that we will take care of the 3 which didn't allow us to carry out direct substitution. Do you get the point now?
Yes, please.
So if this were if you had this to be 4, then denominator 4 minus 3, it won't give me 0. So direct substitution is allowed. So I go and do direct substitution. So for rational functions, direct substitution could be allowed and direct substitution will not be allowed. If direct substitution is allowed, you know it's allowed. So substitute and go. If it's not allowed, manipulate before direct substitution will be allowed. Is that clear?
Yes, please.
And the manipulation technique that we know for now is factorization. So that's what we are doing. So now we know this cancels that, but I won't show my cancellation. So I will go and write this is equal to, okay, my next step, I write my equal to close to the margin. Again, I'm not substituting, so I write my limit. If the limit is not there, I'm doomed. Okay, x approaches what? 3. Okay, then I have what? Okay, 2x plus 7. All correct.
Yes, please.
Are you sure?
Yes.
Yes, please.
No,
Hey,
sir.
remember, it means you are not learning. No. I did the same thing here. I corrected you. I've told you the function that you are taking limit of is more than what? A term. So make sure you always put it in brackets. Other than that, the meaning will change. All correct.
Yes, please.
Okay, so second time. The third time, if it happens in your assignment, it will be M0, A0. You lose the marks from that point going. Okay, so at this point, now because I'm taking limit of what? A polynomial function, okay, no denominator except 1. What do I do? Direct substitution is allowed. So it means wherever I see x in, okay, 2x plus what? 7, I put 3 there. Okay, so once I'm going to substitute, the limit now vanishes. So I'll get 2 into 3, okay, plus what? 7, which in effect will give us what? 6 plus 7, which is what? 13.
Yes, please.
Okay, so now you've not drawn your conclusion. Somebody will come and say, therefore, this is equal to that. But we are smart. We can come and put our therefore here. All correct.
Yes, please.
But as advised, okay, in math, any rough work which is supposed to be done, if this is your page, okay, all rough work must be done on this side. That's the more reason why if you don't rule a line, okay, and you come and write here, whatever that you write here, okay, I'm talking about in your answer booklet or in your books or exercise books. As for your notebook, you can do that, no issues. Okay, so whatever that will be done here, if you don't rule a line, will be treated as a rough work. Okay, so that's why you can say that at the normal circumstance, the whole of this is my page, the whole of this. But I have ruled a line so that if it doesn't go there, I'll come and continue here. So once I have ruled a line, this must be regarded as another page. Is my point well made?
Yes, yes,
Okay, so now this is your rough work. Don't forget to strike it out. Okay, however, you strike it out in such a way that it will still be readable. All correct, my professors.
Yes, please.
Okay, great.
Yes, please.
Okay, great.
Sir,
Yes. Hello,
please,
Professor.
why must we strike it out if it should be readable? Like, if we are striking it out, shouldn't it mean that it's not part of the work? And we also don't
Oh,
want the
okay, continue. I get your question. So I think I can pop in, I can come in, then answer. Okay, this is it. Okay, so for every exams that you are writing, okay, there is a rule. Okay, so here the rule is that anytime you are dealing with your rough work must be cancelled. Whether vital, we have 2 types of rough work. Okay, normal rough work and vital rough work. Okay, usually vital rough work will tell you not to what cancel. In this case, this could have been vital rough work. Okay, but for consistency's sake, we will tell you that all rough work must be cancelled, whether vital or not. Okay, however, when cancelled, it should be readable. Okay, so at the normal circumstance, this was supposed to be part of this, but you decided to, okay, make use of this space so that you will use, okay, a minimum number of what lines that you have here, because now indirectly you are given a constraint paper. Did you see the current WASI paper?
No, please.
Okay, you haven't seen.
No, sir.
Oh wow. But okay, so you were in the house then.
Yes,
Okay,
please.
so but I've showed, okay, maybe you were not. Those who joined the last time, did I show you the nature of the constraint paper?
Yes, sir.
I
Yes,
did.
please.
Okay, so those who don't have, who were not part, don't worry, I will show you. Okay, usually they will write the question up and leave some lines there. And the lines will be too, short for it to take your solution that you have there. So that's the more reason why I said you write what is necessary. So your main work here, your rough work here. So if I was supposed to maybe continue, so let me, just by purposes of getting my point, if I were supposed to continue from here, this is what I would have done. To be the limit. Now, this step here, whatever I've written here will now appear in the numerator. Can you see that? Because I'm factorizing the numerator, then I'll come and write the denominator. The next step, this step will be the numerator, and this will be the denominator. The next step, this will be the numerator, and this will be, so it will become this step. So you can see that indirectly, I've taken about 4 or 6 lines off. I've saved 4 or 6 lines. Can you see that?
Yes, sir.
So that's the more reason why I said anything that possibly you can take it out, deal with it as your rough work, do that to save some lines here. And because there is evidence of work of how you obtain this, okay, if there is a method mark, you will get the method. So if the method for factorization is 2, okay, you will get 2 marks here. So you do it in your answer booklet, not on your question paper. If there is evidence of work and it's on your question paper, you've taken the question paper away. Nobody will see that evidence of work. So you've taken your marks away just like that. Point well made.
Yes, sir.
Okay,
Thank you.
so at that point, that gives us what we have there. So now C. Okay, C. Okay, so let's do C together. Okay, as a class. So what do we write? I want to hear your voices.
X minus 1.
No, so no,
Lim.
we have to write lame. X
X
approaches
X
which is 1.
1.
1 of, okay, X
X
minus
minus
1,
plus
1.
1
X
over
X
squared,
squared minus 6x
minus
plus 5.
okay, plus 5. Okay, so what do I write next? Equal to write? My
yes,
first
please.
step, this is an
Yes,
expression.
please.
So I write
X
the limit, okay, as S approaches what? 1. Okay,
1.
let's see. I didn't even test before, right? Maybe direct substitution will be allowed. If direct substitution will be allowed, then this step, there wouldn't be limit. So let's see. Okay, if direct substitution is allowed, the denominator, okay, S is 1. So 1 squared, which is 1 minus 6 times 1. So minus 6, then plus 5, which will give us 0. Am I right? So we did that mentally. If you can't do it mentally, again, as your rough work, you know that you get 1 squared, okay, minus 6 into 1, then plus 5, which gives you 1 minus 6 plus 5, which is equal to 0. So you know that the denominator will not allow direct substitution. All correct?
Yes, sir.
Okay, great. So once direct substitution is not allowed, okay, it means we need to come and work on this, manipulate this to allow direct substitution. So you come and write the limit as S approaches 1. Okay, then, okay, manipulation that we know is factorization. So numerator is not factorable. So I'll write that one, X minus what? 1. Denominator, okay, possibly could be factorable because it's quadratic. Okay, so let's see. Now, I thank God my leading coefficient is 1. Okay, so I concentrate on the constant 5 here. So factors of 5, that's when I, okay, multiply, I will get 5. When I add, I will get 6. I'll get minus 6, forgive me.
Please, minus 5 and minus 1.
Minus 5 and minus 1. Please, do you all agree?
Sir,
Mm-hmm.
please, can you repeat what you just said again? I
Okay,
was finding
so,
it confusing.
all right, you know how to factorize quadratic expression.
Yes, please.
So that's the concept that you use. So in this case, but we said we have special situation. Okay, if your leading coefficient is 1, you concentrate on the 5. Usually it will be this times that. But if this is 1, this times that will always give you this. So you don't bother yourself to come and multiply. Concentrate on this. Okay, so you get factor pair of 5. That's when you multiply, you get 5. When you add, you get minus 6. Okay, and the factor pair, you just said it will be what? Minus 5 and minus 1. All correct.
Yes, please.
So ordinarily, we would have taken this and factorized using the factorization by grouping. But because the leading coefficient is 1, it's a special situation which indirectly demands a special way of factorizing. And we said if the leading coefficient is 1, once you get the factor pair, you can factorize. So how do I get my factorization here? Remember, we said because it's quadratic, you get 2 linear factors. Okay, the first factor will S term for each of them. Okay, then we said it will be minus 5, minus 1. So I'm going to write minus 1, minus 5. The order doesn't really matter. So here, you know, this will cancel that. So I am going to get the limit, okay, as S approaches 1. Is my point well made, my professors?
Yes,
Yes,
please.
sir.
Okay,
Yes,
then now I know that, okay, X minus 1 here will cancel the X minus 1. So my numerator will be 1. Do you agree?
Yes, sir.
yes,
And your denominator will be X minus 5. Afa. Okay, so
yes,
again, you can see that you are taking the limit of a rational function. So the same, okay, situation, ask yourself whether direct substitution will be allowed. If not, then you go and manipulate. So let's see if direct substitution is allowed. If X, okay, value assumes 1, okay, you are going to get 1 minus 5. Is 1 minus 5 0?
No, sir.
No. So
Minus 4.
it will give you minus 4, which is not 0. So it means, okay, direct substitution is allowed. All correct.
Yes,
yes,
sir.
please.
So once direct substitution is allowed, it means my next step, I'm going to do direct substitution. So when I'm doing direct substitution, the limit should go. So I'll get 1 over, okay, 1 minus 5, which gives us what? 1, okay, over minus what? 4. But unfortunately, remember I told you, don't conclude with a fraction containing a negative in the denominator. So this means we have to bring the negative up. So you get minus 1 over what? Over 4. Okay, and you come in, okay, draw your conclusion here as well. Where is it? Okay, we can put therefore here. Afa.
Yes, please.
Yes.
Okay. Prof. Ernesto, are we fine?
Yes, sir.
Okay, great. All right. Okay, so I think we should all be fine at this point. Okay, if you say so. My professors, okay, those of you who are dozing off, I can see you in the spirit. Are you, are you there? Okay, so make sure you are all on board. Okay, very soon, one of these days, I will ask you to put on, your videos. All right. Okay, so Prof. Michelle,
Mr. Hartman, please, is there any reason the denominator x minus 5 was not in a bracket?
this one. Oh, the bracket will not be necessary.
Yes, please.
You can bring it, but it's not necessary. Remember, I told you if the coefficient is 1, if you cancel, the coefficient will be 1, so the bracket will not be necessary. If you cancel and you had 2 here, any other number apart from 1, then the bracket will be necessary.
Okay, thank
You get
you.
a point. All right. Okay. Even in this one, someone could have put maybe the whole of this in questions. When they put the whole of this in bracket, I'm talking about the whole of this in bracket. You are matured. You know that there's a single fraction. It's a term. So whether it's in brackets or not, the meaning doesn't change. So you are mature. So you can choose after writing it in bracket. The next step, you can ignore the bracket. I hope you get my point.
Yes, please.
Okay, so if you are fine, then I guess we can move on to, okay, so this was supposed to be the continuation of that, but thankfully that slide was able to take the A, B, and C, everything there. So when sending it to you, I will delete that one. Okay, now let's look at another situation. My professors, are we all fine? Is everyone fine? Can we move on to question 4?
Yes, sir.
Yes, please.
Yes,
Wonderful.
please.
All right. Okay, so please make sure you are on board. Okay, all right. So now, again, let's look at, we are taking limits of rational, okay, functions, limits of rational function, but indirectly a different situation from what we've been dealing with. Okay, different in terms of the letters that, okay, our functions are involved. That's all. Okay, however, the concept will be the same. Okay, so now solution is what you write first, then you write what? The question number 4. So I come to question number 4a. Okay, 4a, what am I giving the limit? As h approaches 0 of what function? So a rational function with the numerator 3h, okay, plus what? Okay, 2h squared, okay, then plus 4, okay, h cubed. Or all over denominator h. All correct? I
Yes,
hope my
please.
handwriting is legible.
Yes,
Yes, please.
Okay, great. Okay, so now if we are able to do that, now we ask ourselves, again, you are taking limits as something is approaching 0 of a rational function, is that not it?
yes, please.
So first, once it's a rational function, your concentration, first of all, should be on the denominator function. You ask yourself, if you substitute the value that your variable, in this case, h, is approaching, which is 0, into the denominator, whether the denominator will be 0. And the denominator will be 0, is that not it?
Right.
Okay, so that tells us that direct substitution is not allowed. So we need to go and manipulate. So the manipulation skill or technique that you know, okay, will be factorization. Is that not it? So I'm
Yes,
going to
please.
write this. This is equal to my first step. Okay, so I'll write the limit again. I'm going to manipulate as what? H approaches what? 0. Okay, off. Now, my denominator function, I can't factorize, so I keep it just like it is there, h. Numerator, you can factorize. Is that not it?
Yes, please.
In factorization, I've told you, the first question you ask yourself before you go and use any other technique, okay, or concept will be, do I have a common number that I can bring out? That's a common numerical factor. Do I have a common variable that I can bring out? That is a common variable factor. Okay, so do you have a common number apart from 1? No. Do you have a common variable that you can bring out? Letter, yes, h. So I'm going to bring out h. I hope you are following.
Yes, please.
Yes,
So
sir.
if I bring out h, okay, my terms in my second factor, this is now my first factor. My second factor will be 3 here, plus here, let's go. The whole class.
2h
2h here,
plus
plus
4h.
4h squared. Do you agree?
Yes, please.
Okay, so now we all agree that this h will cancel this h. So in effect, we are going to get the limit as h approaches 0. Okay, my h is not hing. Okay, all right. Okay, so I think it's now better. Okay, of 3 plus 2h plus what? 4h squared. All correct.
No, sir.
Yes, sir.
Hey,
No, sir.
remember, you see,
Let me
third time
get
cuts. Remember, the function that you are taking limit of is more than a term. So you don't forget your brackets. Take note of this. So you know that I've been stressing on it because I know how costly it could be. Okay, so immediately you don't put it in brackets, even if the next step you do the writing, M0 here is 0. So it will be a wasted effort. All right, and time as well. So now we know this is just a polynomial. The denominator is 1. So polynomial direct substitution is always allowed. So I am going to substitute, okay, 0 wherever I see h in that word, simplified function. So that will be equal to 3, okay, plus 2 into 0, okay, plus 4 into, okay, 0 squared. All correct, my professors.
Yes, please.
Okay, so we know obviously this will be 0, this will be 0. So we'll end up getting what? 3 as our answer. So you come and write there for here. Afa.
Yes, please.
Okay. All right. Okay, so should we do one more? Let's do the C, or let's do Let me see. Okay, let's do, which one do you want us to do?
Say please, they see.
I
Please,
saw it coming, right? Okay. So let's do the C, then I'll leave, what do you call it, the B for you to try. Okay, even by inspection, okay, you should be able to give me the answer. So on that note, I'm moving on to C, or we are moving on to C. So C, we are giving the limit. You can see that always when I leave, just I've told you, it's advisable. Just leave some small gap here. In case you want to conclude and you want to come and write therefore here, there will be space there for the therefore. So it's just by experience. Some of these things, they come, okay, by experience. Okay, so now what do we get? It is what? H approaching what? 0. Okay, of what? Of 3. Okay, let me indicate my bar first. Okay, so 3x h squared, okay, plus 4x h, okay, then plus what? Okay, 7h. Is everyone following? All over h. Okay, so direct substitution, is it allowed? Is direct substitution allowed, my professors?
No, sir.
yes, sir.
No. Okay, so this will be equal to, okay, first step. Okay, so once direct substitution is now allowed, I know I'm going to manipulate. So I'll keep my limit as h approaches 0, then come and manipulate my numerator. So it means the denominator will be intact. I'll write that one first. Okay, numerator, you can factor out, okay, h. Do you agree?
Yes, please.
Okay, so if you
Yes,
factor
sir.
out h, what expression will be left in the bracket? Let's go.
3x
3xh
Plus
plus
4x
4x
Okay,
plus 7.
plus 7. I hope you are all in agreement.
Yes, please.
Okay, you are doing well. Keep it up. So now again, you know that the h will cancel the h here. So we are matured now. So we are not going to show the cancellation. So we know this will be equal to, okay, I'm going to get, or we are going to get, okay, the limit as h approaches 0 of what? 3xh, okay, plus 4x, okay, plus what? 7. Hope I'm right.
No, sir.
Okay, so here today, I mean, this time around, I didn't hear, okay, yes. So this must be in brackets, so take note of that. Okay, so now direct substitution is allowed. Wherever I see h in, okay, my expression here or function here, I substitute for 0. So that is going to give us what? Okay, 3x into 0, okay, plus 4x, there is no h there. Okay, then plus what? 8. Sorry, 7. So forgive me. So in effect, you know that this will go. So you'll be left with these two terms. All correct.
Yes,
Yes.
please.
Okay, so now we are going to get equal to 4x, okay, minus what? Minus 7. Okay, so on that note, you can come and write there for, okay, here we are done. Safa. Okay.
Sir,
Uh-huh.
sir, please. I thought it's supposed to be 4x plus 7.
Oh, did I write minus? Forgive me. Hey, it's too early for me to be exhibiting symptoms of hunger. All right, forgive me. Okay, so it's supposed to be plus. So it means she was the only one, okay, who will get the final answer right. Okay, the rest of us will get it wrong. Okay, so it's supposed to be plus 7. Okay, all right. Okay, so now, like I always say, anytime some of these petty mistakes are equally, then it means indirectly God wants you to know that you should also be careful in this situation. Okay, so let's look at the B, mentally. Okay, what do you think? What do you call it? What do you think the limit will be mentally?
So please, it will be 7.
It will be 7. Please, do you all agree? Okay, the H will come out, it will cancel. So the only term that will not contain H is the only term that will remain after you substitute the H, which will be 0. Okay, so that will be what? 7. Safa. Oops, Daisy. Okay, don't worry. Okay, I think I can clear it. I should have disabled my annotation. Okay, so I think it's a way of God. So let me disable my annotation so that no one. It's up. Are we all fine?
Yes, sir.
Okay,
Yes.
great.
Yes.
Okay, so now, okay, if we are all fine, then, okay, I am going to give you about 4 minutes water break. Okay, so if you come back, then we'll look at, okay, this should have been the continue. We look at questions of this sort. You can see said, okay, in the question, how best to deal with this. Okay, Prof. Baini, can't you wait so that when you come back from the water break, or I should go back? Okay, so Prof. Bani, let's come back from the water break, then you ask your question, okay? All right, thanks for your understanding. No one is leaving, so let me pause. Okay, so you are welcome back from your water break. Now let's look at our next set of questions. Okay, so what are we supposed to do? Question 5, find, okay, the following. Okay, so you've been given limits, but like I said, okay, before the break, this time around, you can see that the limit of your function is a rational function indirectly. Okay, all right, but you can see a set in play. So let's see what you are supposed to do in situations like this. So maximum attention, please, at this point. Okay, a lot of algebra will be involved. Okay, and I'll be giving you, okay, pieces of advice. So please, okay, make sure you take note of them. All right, so now, after reading the question, you check if you can underline any salient parts. Okay, and here, no. So what do? We now go and write solution, then write the question number, which is question number 5. Oops. Okay, so major question number 5, and we are looking at solution to minor question number A. So we leave a space, just a little space to take therefore, in case we want to put the therefore there. Then we come and write the limits as what? X approaches which value 2 of which function. So it's a rational function. The numerator function is a pretty one. Okay, 4 minus s squared. The denominator function is 4 minus not pretty at all, root of, okay, s squared, okay, minus what, or plus 12. All correct, my professors. So this one is just copy and paste, basically. It's just copy and paste, whatever that we were given. So now this will be equal to, it's an expression. So you start your steps with equal to. If it's an equation inequality, you start with implication. So let's see, okay, whether direct substitution will be allowed. If direct substitution will be allowed, then I come and continue with my direct substitution. So now it's a rational function. So for a rational function, you must first investigate whether direct substitution is allowed. And that one, okay, you concentrate on the denominator. So I can do it mentally. Okay, I will do it mentally and later go and write. So wherever I see x in this denominator expression, it will be 2. So I know I'll get 2 squared, which is 4. 4 plus 12 will give me 16. Root of 16 is 4. So it means I end up getting 4 minus 4, which is 0. Is my point well made?
Yes, please.
Okay, so if you can't do it mentally again, okay, you are doing 4 as your rough work minus root of 2 squared, you know, that one you can do it mentally. 2 squared will be 4, then plus 12. Okay, I've substituted wherever I see, so let me write the 2 squared there, maybe, so that the next step will be 4 minus root of, okay, 4 plus 12, okay, which will give you 4 minus root of 16, which will give you 4 minus 4. So that will give you 0. So it means now we all know comfortably and convincingly that direct substitution is not allowed. Okay, direct substitution is not allowed. Okay, but now let's see. My numerator function, maybe I can factorize difference of two squares. That will give me 2 plus x in one bracket, in another bracket 2 minus x. But that will not result in anything beneficial. That will cancel something in the denominator and take care of what is not allowing direct substitution. So it means here factorization as a way of manipulation will not be that useful. So we have to resort to another manipulation technique. Okay, and that will be rationalization. Rationalization, and we all know how to rationalize. Okay, we will learn another concept. You know, rationalization instead, you did rationalizing the denominator. Is that not it?
Right.
So the first one that we have here, the third is in the denominator. So if you want to rationalize, you rationalize the denominator. So which we are all comfortable, or we should all be comfortable with. So at this point, I know we are going to manipulate. So I'll write the limits. Okay, oops. Okay, so x approaches what? 2. Okay, off now I know. So let me go and clear this because maybe I will need space for this. Okay, I've told you this wouldn't be necessary. Okay, you can do it mentally. If it's necessary and you know yourself more than I do, so you write it and cancel because that's your rough work. Okay, so now this is what I do. Okay, I am going to rationalize, this. So it means I need to write this again, look for the conjugates of the denominator and multiply both the numerator and the denominator by the conjugate. All correct. Remember rationalization. So 4 minus s squared, over 4 minus root of what? S squared, plus 12. That is repeated. Then times, what will be the conjugate of the denominator? Who wants to help? You put up your hand, then you tell me. Okay, Prof. Now, Amale.
4 plus square root x squared minus 12
This will be minus.
plus 12.
Okay, did you say minus initially?
Yes, please.
Okay, all right. I thought maybe I heard you wrongly. Okay, so it should be plus 12. So for binomial, said, if you are finding the conjugate, just change the signing between the terms. That's all. So this is the signing between the term. Okay, this is minus, so it changes to positive. As simple as that. If it was positive, the conjugate will take the sign negative or minus, I should say. So addition will be subtraction. Subtraction will be what? Addition. Okay, so I guess, your question is answered. That's why your hand has gone down. Okay, all right. Okay, so now what do? We are going to multiply both the numerator and the denominator by that. So the conjugate we said will be 4 plus. So it will be numerator will be 4 plus root of. Please don't write, just listen. I'll give you time to capture or even write. I've advised you it's better you capture than write. Okay, so 12. And when we are done, at the end of every lesson, I'm talking about particular topic, I will send the slides to you so that those who want to print, do whatever you can do that with it. Okay, so now this is what we have. Okay, then s squared, yes.
If we're able to copy everything into our books, will it be okay?
If you are able to copy.
Yes.
Yeah, so that's why I said this one freedom. Okay, I will share the slide. Okay, after every topic, when we are done, we are moving on to the next topic. I will share the slide. So if those of you would want to print, okay, you have it available to print. And those of you, if you have already written what you have there, then maybe you won't see the need to print. Okay, so you can keep it anyway in times of need. So my point is I'll make the notes available to you. All correct?
Yes, sir.
Okay, so now this is after you have rationalized, please, this is the advice. The side that you rationalize, that is the side that you expand. The side that you didn't rationalize, that side you have to keep the expressions. So if you look at these two, okay, numerator, denominator, you can see that we rationalize the denominator. So when you are multiplying, it is the denominators that will expand. Okay, numerator don't expand. And I'm going to repeat this. Where you rationalize, that's where your expansion will be done. Because anytime you multiply a set by its conjugate, you know, okay, that its expansion will lead to difference of two squares. So that one you can easily expand. All correct?
Yes, please.
Okay,
Yes.
so I'm going to go by the same advice. I'm not substituting, so my limit should still be there. So the limit as what s approaches 2. Okay, then now remember we said numerator, I didn't rationalize. So I'm going to keep my numerator as what? 4 minus s squared 2 times. I put it in bracket. Multiplying other 2 terms, which is 4 plus root of s squared plus 12. All correct, my professors?
Yes, sir.
Okay,
Yes,
my
please.
denominator, I know. Any set multiplying its conjugate will give me difference of 2 squares. So I don't have to go and do this one times this one, okay, this one times all the terms here, this one times all the terms here. No. I know if I multiply, I'm dealing with an special binomial. Same first term, same second term, difference in kind. So if you multiply, you get difference of 2 squares. So that will give me 4 squared. Okay, then minus, okay, root of s squared plus 12 all squared. All correct, my professors? Or I should come again?
So please come again.
Please come again.
Okay, all right. So let's see. All right. Okay, so just from the known, then you've all done said, right?
Yes.
Yes, please.
Okay, so if you were given, assuming you were given, okay, 1 over 2 plus root of 3, and you are rationalizing, you know, you write again, you come and write times, okay, 2 minus root of 3 over 2 minus root of 3. Is that not it?
Yes.
Yes,
Okay, so you write this is equal to, okay, you keep this 1 times this will give you 2 minus root of 3. And you are going to get this one. You can see that it will be this binomial multiplying this binomial. So I'm going to write it just for explanation purposes so that I can make my case. Okay, so it will be this. Okay, and okay, you were advised when we were doing algebraic expression, factorizing, expanding, especially binomial terms. I said if you have two terms and you are two factors and you are multiplying, check whether the factors, okay, binomial factors, they have the same first term, the same second terms, okay, and different sign. If you have a plus b times a plus b, you know that this is the same as a plus b squared. Do you agree?
yes, please.
Okay, which you know its expansion, which you give us, you know, we gave you the identity a squared plus 2ab plus b squared. So those of you who are mature can get expansion this way. Those who are not mature will come and do this time, they later come and combine and get this. Okay, so that one will indirectly disclose their immaturity. But if you are mature, then you have a plus b multiplying a minus b. You know, once you have same first term, same second term, this, okay, indirectly is a factorization of difference of two squares. But if you expand, it means you should get a squared minus b squared. All correct.
Yes, please.
So it's the same concept idea that I use here. The 4 is my a. Okay, so it's a minus b multiplying a plus b. Okay, multiplication is commutative, so the order doesn't really matter. So that will give me my first term here squared of, yes, which is 4 squared. Then my second quantity here squared, which is what I have here. I multiply, I get difference of 2 squares. Alpha. Point well made, my professors.
Not
Hello.
fine. Not
Should I
Yes.
still
fine.
come again or my point is well made now?
Please still come again.
Mom Caroline, what happened?
Please, I'm a little confused here. Like,
Eh,
please.
just here. So this time around,
Yes,
your light is dim.
sir, please, I'm not well.
Oh, you are well. Okay, so let the week say
I'm strong.
Very good. Okay, so let the unwell say.
Um,
Okay, all right. So that's it. Okay, so this is it. So this is the concept. At the normal circumstance, if you are not mature, okay, you would have done 4 times this. Okay, which would give then you come and do 4 times this, 4 times, but you end up getting the result that you are going to get. So if I give you A plus B, multiplying A minus B, okay, someone who is not mature will come and do A squared, okay, minus AB, okay, then plus AB, then plus B squared. And that will end up giving the person A minus B squared. Is that not it? So this will give you
yes,
minus B
please.
squared, not plus. So that you end up getting this. Someone who is matured will know that once I have same first term, same second term, difference in sign, if I expand straight away, I'll get difference of 2 squares. You get it?
Yes, please.
So that's what I used here. What you have here will be 4 minus root of this one. Okay, then multiplying 4 plus this. So the same first term, same second term, difference in sign, just like this. Same first term, same second term, difference in sign. Okay, for the factors. So if I expand, I will get my first term, okay, here squared, minus the second term here squared. Is it clear now? Prof.
Yes,
Carol?
please.
Okay, all right. Okay, so I think your positive confession, okay, has worked. Okay, so going forward, adopt that. Okay, so that will give us, this will be equal to, okay, so remember, okay, the numerator, no matter what the spirit tells you, whichever spirit, don't expand. Okay, so x, okay, approaches 2. So numerator will be kept intact. It will still be 4 minus what? X squared. Okay, then into what? Okay, 4 plus what? Okay, 4 plus root of x squared plus 12. I hope you are following. Is everyone following?
Yes, please.
Okay, don't forget to close your brackets there. Then denominator 4 squared we know is what? 16. Is that not it?
Yes, please.
Then minus, okay, the square here will get rid of the square root here. Do you agree?
Yes, sir.
Yes,
Yes, sir.
So
please.
I will be left with s squared, okay, plus 12. Do you agree?
Mhm.
Think through very well. Oh. Do you agree?
It shouldn't be
Yes,
minus
sir.
12.
It should be in brackets first. Unless you want to push the negative through, then this will be minus. So it should be in bracket first. Because what you have after the subtraction is more than a 10. Is that clear? So
Yes,
take note,
Yes,
other than that,
please.
the meaning changes. If you remove the bracket and wrote minus here, that will be correct. That will be the matured way. But you can't keep what the plus there. Okay, so on that note, this will be equal to again. Okay, I'm not doing my substitution, so I'll keep on writing my limit as s approaches 2. Okay, numerator, remember intact. Okay, that spirit, okay, you rebuke that spirit that will tell you to expand. Never expand. Okay, then you get what? 4 plus what? Root of what? 12. Okay, sorry, x squared. Okay, plus 12. Okay, then you close it. Then denominator will give us, I'm going to write it just for explanation's sake. Going forward, you are mature, so I will skip that. So that will give you 16 minus s squared. Okay, is that 16? Okay, so let's go minus s squared minus 12. Do you agree?
yes, please.
Okay, so numerator again. So I'm going to write this limits. Just listen. Okay, I've told you I'll give, let's do it together. So the very first example under this time, this type. Okay, so numerator. Okay, Prof. Normally.
Sir, please, how did you get the minus 12?
Oh, so there is a negative here. So you push the negative through. So it will be negative times this, which is negative s squared, and negative times this, which will give us this. Apa?
Yes, please.
Okay, all right. Okay, so now we are going to get what? 4 minus s squared, one of the factors in the numerator, And the other factor is what? 4, okay, plus root of s squared, okay, plus 12. You close it. Then the denominator will give you 16 minus 12. That will give us 4. Okay, then minus s squared. All correct. All correct?
Yes.
Yes,
Okay, so
please.
now you can see, just because you didn't expand the numerator, okay, you can see that there is a factor here that can cancel this factor. Okay, you know, before you can simplify any algebraic fraction, numerator, denominator must be factorized. But you can see that what you have here indirectly is in its factorized form. Okay, only that it's not completely factorized, but no worries. Where it becomes necessary to completely factorize, you factorize. But the denominator obviously is not in its factorized form. So that one I said we expand and we simplify. So now this will cancel that. Are we all in agreement now?
Yes, please.
Sure. Who wants me
Yes.
to come again? Okay, the multi-million question. Okay, and from where? So I'm going to clear this, make room for the continuation of whatever that I'm going to write. Hello, my profs. Are we there? Is everyone okay?
Yes, please.
Yes, please.
Okay, great. Okay, we thank God. So we are going to continue from there. Okay, then after that, I think we have about 1 or 2 more. Then we should be done. Okay, all right. So let's go and continue. So I take my pen. The next step equal to. Okay, so let's see. We know that we are going to get the limit as what x approaches 2. Of we know this will cancel this. So let me cancel. Okay, this is the first, but you are matured enough to know that, okay, you can do the cancellation mentally. So you end up getting 4 plus root of 4 or root of, so is it, no, it's into 4 plus, no, it means I did something wrong. No, that's it. There is nothing wrong. It's supposed to be 4 plus. So there is nothing wrong. I haven't done anything wrong. Okay, so let me clear this. Okay, and the person whose hand is up, okay, I will call you very soon. So it will be 4 plus, okay, we are left with 4 plus, oh, so what I'm writing was correct. Okay, 4 plus, okay, root of s squared, okay, plus 12. Okay, so, what do you mean? Okay, hey, Prof. Gideon.
We can skip. We can skip the step that the negative came before the bracket. We can skip that.
This one, you can move from here, okay, to here directly. That's why I said, okay, I was writing this just for explanation purposes. But those of you who are matured can move from here. You won't lose any marks.
Okay, sir. Thank you.
You are welcome. Okay, so please, any question, any further questions? If not, okay, do you agree with what I've written here?
No.
A big no. That's what I was expecting to hear. Okay, so what is missing?
The bracket.
The bracket, very good. Okay, so you bring your bracket now. Okay, there is no denominator function, so always direct substitution will be allowed. So I'll end up getting 4 plus root of, okay, my x is 2, so that will give me 2 squared. Let me substitute first. Okay, then plus 12. As you mature, you know what to do. Then you get 4 plus, okay, root of 2 squared plus 12, which is 16. Okay, so I'm going to get 4 plus root of 16, which is 4. So that will end up giving me 8. After, then I'll come and write therefore here. All correct, my professors.
Yes, please, Mr.
Okay. Any questions? Hello, profs. Any questions? This is the first example. You can see that this one, apart from you knowing the concept, okay, everything, okay, is basically on your algebra. So that's why I say relative math, okay, is your algebra. So your core math must be strong. Core math is algebra. So relative math, when you get the principle, then you apply your core math algebra in dealing with it. That's all. Hard math is always like that. Okay, so we are going to do maybe one more. Okay, I am going to maybe do the C together with you, or maybe do the B. as a guide, you do the C. Or between B and C, again, let me, as for D, it's in red. So it means definitely, most likely it will be your assignment. Okay, so I won't touch it. But between B and C, which one should we go for? We should do the B, then you try the C on your own, but you don't submit. Is that fine with you?
Yeah.
Okay, great. Okay, so let's do another example. As for this one, I wouldn't even ask whether one example is okay. I know it will not be okay. So we are going to move on to, okay, the B. So I'm skipping to the next, okay, slide. Okay, so B, so for 5B. So B, what are we giving? Okay, the limit, okay, as x approaches what, 2 of what? 4. So let me indicate my fraction. Okay, 4 minus root of x squared plus 12 all over 4 minus x squared. Okay, all right. So again, we ask ourselves, okay, we are taking limit of a rational function, a function of another function. So we ask ourselves, okay, is direct substitution allowed? Okay, and the answer is yes or no?
No.
No, direct substitution is not
No.
allowed, because if you substitute x equal to 2, you get 4 minus 2 squared, so it will be 4 minus 4, which will give us 0. So direct substitution is not allowed. Once direct substitution is not allowed, we have to think of manipulating to make direct substitution possible. So in this case, you check. I've told you, anytime you have a set in play, you should know that the manipulation process will not be factorization, but rather rationalization. Is that correct? Is that clear, my professors?
Yes, sir.
Sure. Okay, so now, okay, I know I am going to rationalize, only that this time around, for your first time, you are rationalizing the numerator. Okay, so in terms of limits, we rationalize both numerator and the denominator to achieve a particular purpose. Is my point well made? Am I clear enough?
Yes, sir.
Okay, so now my first step equal to, okay, I'll write my limit again as s approaches 2. Okay, then come and write my function again. So 4 minus root of s squared, okay, plus 12, all over what? 4 minus what? X squared. Okay, so I'm rationalizing the numerator this time around. So I have to multiply both the numerator and denominator this time around by the conjugate of the numerator. So the conjugate of the numerator is what?
4 plus root x
Root
squared.
x squared plus 12.
Is what? 4 plus, okay, so the same conjugate that we had initially for the other one denominator, you can see that it's basically the same set. So 4 plus root of, okay, s squared plus 12. Okay, all over 4 plus root of s squared plus 12. Please, if you don't get to talk, I've taken my time and I'm walking you through this. In school, like I always say, you won't get this. Find opportunity. Okay, so now what do we do? Okay, the next step, this will be equal to, okay, which side, per the advice that I've given you, which side are we supposed to, okay, keep? We don't expand. And which side are we supposed to expand? Numerator or denominator? Which side, numerator, per what I've told you, are we going to expand or we won't expand the numerator? The entire class.
Please,
We won't.
We will
Yes.
expand it.
We won't expand which one?
The
The
numerator.
numerator.
The numerator.
Yes, sir.
Oh, then you didn't get my point. Then you didn't get my point right. Remember, I told you the side that you rationalize is the side that what you expand. So the other one, we rationalize the denominator, so we expanded the denominator. This time around, we rationalize what? Numerator or denominator?
The numerator.
Numerator. So it means the numerator that we have to expand, the denominator we don't expand. All correct now?
Yes, please.
Oh,
Are
yes.
we all fine now?
Yes, please.
Okay, great. Okay, so now that we know this, okay, we are going to keep to that. So the limit as s approaches 2. Okay, my denominator, I'm not going to expand, so I'll keep it intact. I'll write that one first, little or no work. So it will be 4 minus s squared in one bracket, then in another bracket, okay, 4 plus root of, okay, s squared plus 12. Okay, I close my bracket. Then my numerator, I'm going to expand. And I know I'm multiplying a set by its conjugate. So it will always give me difference of 2 squares. So it will be my first term, which is 4 squared. Okay, minus my second term, which is root of s squared. Okay, plus 12, the whole of that squared. All correct?
Yes, please.
Oh,
Are you all
yes.
fine? Carol, are you fine now?
Yes, please. I'm
Okay,
fine.
great. Okay, so now, okay, that spirit is gone and gone forever. Okay, so this will be equal to, okay, so now, again, we keep the limits. We are not substituting. We are still dealing with the simplification that will help us do direct substitution. So remember, denominator intact. So I'm going to write 4 minus s squared, okay, into 4 plus what? Root of s squared, okay, plus 12. I close the numerator, I'm going to expand. So 4 squared will give me, okay, 16. Then minus, this time I'm going to deal with it maturely, like someone mentioned. So I know this will give me minus s squared, okay, then minus 12. All correct.
Yes, sir.
Please, do you all agree? You know
Yes,
yourself
please.
better than I do. If skipping that step will be costly to you, don't skip. Okay, until you are mature to protect your marks. So this will be equal to, okay, so I keep the limit, okay, as s approaches 2, then my denominator again will be intact. And that will be 4 minus, oops, okay, s squared. Let me clear that. I almost wrote plus. Okay, so 4 minus s squared in one bracket. In another bracket, we have 4 plus root of s squared plus 12. You close it. Your numerator now will be 16 minus 12, which will give us 4 minus s squared. All correct. Our professors, are we all fine?
Yes, please.
Okay, so now you know this, okay, obviously we'll cancel this, but I'm not going to cancel, show my cancellation. So we'll be left with the limit. After we have cancelled, we'll be left with the limit as x approaches 2. Of your numerator will be 1. Do you agree?
Yes, sir.
And the denominator will be what? The whole class. Let's go.
4 plus
4
4
plus
plus root
root
of
root of
x squared.
s squared
square.
plus 12. Okay, so now we ask ourselves whether direct substitution is allowed. Okay, so let's see. If x is equal to 2, you get, okay, 4 plus what? 12, 16. So you get 4 plus root of 16, which will be 4. So you get 4 plus 4. So direct substitution will be allowed. Is that not it?
Yes, please.
Okay,
Yes,
so
please.
now we are going to get one direct substitution. We are substituting directly. We keep, okay, we don't write the limits. So we are going to get 4 plus root of, okay, 2 squared, okay, then plus 12, which you know will give you 1 over 4 plus root of 16. Okay, which will give us 1 over 4 plus 4. Okay, which gives us what? 1 over 8. And it makes sense. If you look at this function that we have here, that we are taking the limit to, it's the same limit that you are taking, but you can see that is the reciprocal of this function. So the answer that you get here will be the reciprocal answer here. Its reciprocal will give us this. So the other one, you remember you had 8, and now we are getting 1 over 8. Point well made.
Yes, please. Yes, please.
Is my point well made, my professors?
Yes,
Yes,
please.
Yes, please.
Yes, please.
Okay, great. Okay, so on this note, maybe let's see whether time will allow us to explore, okay, the C up to a point. Okay, then later you continue. Oh, you said Mr.
Right.
Hartman. Mr. Hartman, give it to us. Don't touch anything. Okay, don't start anything for us. We will do it. Okay, as for the last one, it will be your assignment. I guess yes, that will be your assignment. Are we fine?
Yes, please.
Okay.
Yes, please.
Or maybe I can change my mind. I should rather give this one to you as your assignment. Okay, I will give this one to you as your assignment. Okay.
Yes, please.
I think, okay, for me to be convinced that you are fine. Okay, so let me quickly, okay, do this. Okay, so that will be the end of what today's, okay, class. Okay, and I have enjoyed the class and I believe, okay, you also, okay, did. All right, remember, we've not drawn our conclusion. So let me come and write my therefore, okay, here. Take note. In every question, before you move on to the next one, conclusion must be drawn. Okay, as always. Okay, so on this note, I'd want to say thank you very much for sticking and staying with me for your time. Okay, may the good Lord continue to bless us all.